Hello, welcome to this class. In this class, I'll be solving this simple circuits for you. In this question, we are asked to determine the voltmeter reading in this circuit. Now, if you look at this circuit carefully, you will see that we have two sections, this first section and this other section of the circuit. Here, this is a 400 ohm resistor, another 400 ohm resistor, and they are connected in parallel. Now we're told that this voltmeter also has a resistance of 800 ohms. So the resistance of this voltmeter is also parallel to the resistance of this resistor. So when current leaves from here, we know that the current will flow through and get to this point, which is a node, and the current will split, ensuring that this portion and this portion are in parallel. So the first thing I will do is to calculate the effective resistance of these two. And let me call that R1. So 1 over R1 equals to 1 over 400 plus 1 over 400. So 1 over R1 equals to, the LCM is 400. You have 1 plus 1. So 1 over R1 equals to 2 over 400. When you invert both sides to get your R1, so we have 400 divided by 2. So the R1 in this case is 200 ohms. So the effective resistance of these two together is 200 ohms. Permit me to write it here, 200 ohms, that's our R1. Now the resistance of this voltmeter is 800 and it is parallel to 800. So the effective resistance there, let's say we call it R2. So 1 over R2 equals to 1 over 800 plus 1 over 800. So the LCM here is 800. We have 1 plus 1. So the 1 over R2 equals to 2 over 800. If you invert that, then the R2 equals to 800 over 2, and R2 equals to 400 ohms. So the resistance here is 400 ohms. Now this resistance and this resistance are now in series. So to find the effective resistance of the circuit is going to simply be R1 plus R2. So the resistance of the circuit becomes 200 plus 400, and that gives us 600 ohms. Now from Ohm's law, we can compute the current in the circuit because we know that V equals to IR. The V has been given as 6. So you have 6 equals to I multiplied by the effective resistance, which is 600. We divide through by 600, and you divide through by 600. This cancels out, and the current in the circuit equals to 0.01 ampere. This is the current in the circuit. Now, to obtain the voltmeter here, we know that what leaves here is 0.01 ampere. So this current flows in this way. And when it gets here, it splits. Of course, since the resistors are the same, it splits into half of each. The current flows in here, and it recombines and flow into the system. So the current that entered this system is 0.01. Okay, so to get this voltage, we'll simply apply Ohm's law again, applying Ohm's law again. So this voltage here becomes V equals to IR. The current is 0.01. Since this current is shared by the voltmeter and this resistor, it means that the net resistance will be used, which is 400. And this gives us 4 volts. So the resistance, the voltmeter reading in this question is 4 volts. And this is the answer to the question I want to encourage you to please subscribe to this channel so that you can get more educative videos. Thank you for watching.